Okay, the first type of sequence we're going to work with today is called an arithmetic sequence, spelled arithmetic. And then the second part is called the geometric sequence. Okay? Both of them have simple patterns that between terms that are pretty easy to find. Okay, arithmetic sequence have what's called a common difference. And geometric sequences have a common ratio. Okay, between each pair of terms. Now, so the first thing you do is determine which is an arithmetic, which is a geometric sequence. Okay. So again, so you just know how many common differences, ratios there are between the first term and the nth term. Okay. All right. So we go. So in part A, we go from 5 to 8 to 11 to 14 to 17. So does it look like a common difference or a common ratio?
Ratio.
Yeah. Difference, right?
I thought difference was subtracting.
Yeah, it is.
You're not subtracting, though, you're adding.
Well, okay, same type thing, right? I mean, subtracting is just the opposite. This like, so you're adding you're subtracting a -3 or whatever, if you want to look at it that way. Okay. In other words, okay, when it says common difference, that just means that there is a specific number, a number that we add or subtract either way to get to the next term. So in this case, what is our common difference? Our common difference is 3, right? So in other words, what we're saying, Larissa, is the difference between consecutive terms is 3. Okay, that's all that is. And I understand what you're saying, okay, but in this one, difference doesn't mean subtraction necessarily. It just means, how do I get from one term to the other? In this case, I add 3 to each term. Okay, so if it has a common difference, what kind of sequence is it? Arithmetic, right? It's an arithmetic sequence. Okay, all right. So now let's look at part B. So we go from 5 to 15 to 45 to 135. So this has a common ratio, and what is my common ratio here? It is 3. So what kind of sequence do I have? That's a geometric sequence, okay? So if you multiply or divide from one term to the next, that's a geometric series. If you add or subtract from one term to the next, that's an arithmetic series, or sequence, I should say.
Why are you saying arithmetic?
Because that's the word.
So it's not like, does it deprive from arithmetic? Or what?
Derive from arithmetic? Yes. Yes, it does. But to differentiate between that, we say arithmetic. It's not an arithmetic sequence, it's an arithmetic sequence.
Is
Right.
arithmetic
That sounds
and
messed up.
arithmetic the same thing?
Okay, let's not delve too deeply into this, right? It's just the name of that type of sequence. If you have a common difference and you add to get to another one, it's an arithmetic sequence. Let's leave it at that and move on. All right? All right. Okay. So now again, so to find the common difference, take any term and, well, in this case, if you take any term, and now it talks about the one before it, so we're going to subtract the one before it to get our common difference. Okay? So in other words, so the common difference is equal to a sub n minus a sub n minus 1. Okay, to find the common ratio, take any term and, yeah. Oh, gosh. And divide it by the one before. Okay. So now, and again, remember when I say common difference, that means it's always the same. All right, and the difference or ratio between two pairs of terms must be the same throughout the entire sequence, or it's not. Then, or if it's not, then it's neither arithmetic nor geometric. Okay. Now, each formula also leads to recursion formulas, which we will talk about in a moment. Okay. Okay, so if the sequence doesn't have a common difference or common ratio, just like we said, then it's neither arithmetic nor geometric. Now, in this section, we're only dealing with arithmetic sequences, okay? Now, two formulas are going to be very helpful in this section. So the first is what we call an nth term formula. So if you want to find the nth term, okay, in an arithmetic sequence, we're going to take the first term, and then we're going to take 1 minus, and then plus n minus 1 times the common difference, okay? So And then the next formula is the sum. So if we want to find the sum of the first n terms, which is always denoted with an s, okay? Generally, when you're finding an nth term, it's denoted with a sub n. When you're finding a sum, that is s sub n. Now, the sum formula is on your formula sheet that I think I told you I was going to copy that off and give it to you, didn't I? I will do that after the lesson today, okay? Yes?
Is the S the sum of the other one, the first one?
No, it's just a sum of, okay, so like if you look back at the previous examples, so we had that one that was 5, 8, 11, Say I wanted to find the sum of the first 15 terms of that sequence, okay? Then I would use the sum formula there. If I wanted to find what was the 15th term, then I would use the one on the left, the nth term formula. If I want to find the sum of all those terms, I would use the S formula, the sum formula. Okay, and we'll do examples of all those here in just a second. Okay, all right. So now you'll also need to be able to find a general formula or an nth term formula for a sequence. Okay. So let's just do some examples here, and then you'll see what we're doing. So we want to find an nth term formula for the arithmetic sequence, and then find the 101st term. So here I've got a, and a is always a sub 1. So that a there, this a right here, that is our first term. Okay, and our common difference is 3. So we're going to take these, we're going to plug them into our nth term formula here. Erase that, okay. And then come up with a formula specific for this sequence. So we get a sub n. That paused on me. Okay. Okay, so let's do this again. So we want to. It didn't record last time, so I'm going to redo this. We'll do it kind of quickly here. Okay, so we want to plug it into the nth term formula here. All right, so we get a sub n is equal to a sub 1, which is negative 2. And again, whenever it says a, that means a sub 1. So we get negative 2 plus n minus 1 times our common difference, which in this case is 3. Now we distribute our 3. So we get negative 2 plus 3n minus 3, and then we just combine. Okay, now then we combine like terms, so we get a sub n is equal to 3n minus 5. Now if it wants a 101st term, that's a sub 101, so I just take 101 and plug it in for n. So we get 3 times 101 minus 5, which gives us 298, and that is the 101st term. Okay?
Right after.
Yeah, anyway. Then if I wanted the 50th term, I'd plug 50 in. If I wanted the 357th term, I'd plug 357 in. All right? All right. Okay. Let's look at part B now. So again, a sub n equals a sub 1, which is 5 in this case, plus n minus 1 times 2. Negative 2. It's what I said. Can't believe you guys thought I said 2.
I have it on record.
Not yet, you don't. All right, so we distribute that negative 2. And we get 5 minus 2n plus 2. So then our formula then is a sub n equals negative 2n plus 7. Now again, if we want the 101st term, we have negative 2 times 101 plus 7. So negative 2 times 101 is negative 202. Plus 7 is, there's your 101st term right there, negative 195. All right, so now there may be some problems. It says where you ask to identify the common difference of the formula. Okay, this can be done by 1, writing out the first 4 or 5 terms and then figuring out what the difference is, or 2, use the formula for the common difference at the beginning of the notes. Frankly, usually writing out the first 4 or 5 terms is probably the easiest way to handle this. Okay, so if I have n minus 5, so what's my first term? Okay, well n is what? N is 1, so my first term is negative 4. Good. What's my second term? Okay, negative 3. What's my third term? Negative 2. What's my common difference? It is 1. Good. Okay, so now we're ready, right? So now we get a sub n equals, no wait, what would they want us to do? Oh, but find the common difference. Oh, never mind. Yeah, I was going to say we're going to get the same thing. Yeah, there's our common difference right there. We're done. Okay. Now, with that in mind, what's our common difference on B? Do you think it's going to be? Okay, I've heard 3. I've heard what did you say, Matt? You're not even watching, so you don't count. Okay, all right, I've heard 3. All right, let's see. So what's our first term? A sub 1 is 1. What's our second term? 4. What's our third term? Oh, so what's our common difference? It is indeed 3. All right, so again, with that in mind, what's on part C? What's our common difference? Yeah, it's just simply negative 2. All right, so that number in front of the n is always going to be your common difference. All right, so that's pretty much all the information you need now. Now let's run through some of the different types of problems that you're going to see on your assignment. Okay. So now example 4 says, what is the 80th term of negative 1, 1, 3, 5? Now we could count that up, and it's pretty easy, right? But it's going to take us a while to figure out the 80th term. So we need to come up with an nth term formula here. So what are the two things we need to know when we're developing an nth term formula? We need to know the first term and the common difference. Okay? So here, what is my first term? And what's my common difference? 2. Rock and roll. We're ready. So we got a sub n is equal to a sub 1, or the first term, plus n minus 1 times d. And we want the 80th term. Now, you don't have to do all your distribution right now if you don't want to. Okay? We can just plug it in and solve it like it is. Or if you like to distribute it and get a nice, negative 2n, or 2n minus 3 or whatever, that's fine too. It really doesn't matter. Okay, but I can also just plug 80 into this. So I get negative 1 plus 80 minus 1 is 79 times 2. So 79 times 2 is, say, 158 minus 1. There's your 80th term right there.
Why did you get 79?
Because this was n minus 1,
Oh.
and n is 80, so in the 80th term. Okay?
Still got some.
Absolutely. That's the beauty of it, Austin. All right, now, example 5, and again, I'm going to tell you, Slick loves these types of problems, okay? So they're going to give you two random terms in a sequence, and you have to come up with a formula for it, okay? So let's see how we do. All right, so we have the 4th term is 3, and the 20th term is 35. Okay, so let's think about this for a minute. So I know a sub 4, that is 3, okay? So now let's generate a general formula for that. So if it's the 4th term, then I have a sub 1, which I don't know, correct? And then plus n minus 1. Now what is n in this case?
4.
N is 4, because it's the 4th term. Okay, so I get 4 minus 1 is 3 times my common difference, which I also don't know. Okay, so now I've got that right there. Okay, let's do the next one now. Let's do a sub 20. Okay, so we know our 20th term is 35. And again, that's equal to a sub 1, which we don't know, plus n minus 1. And what's n in this case? 20. Okay, so 20 minus 1 is 19 times our common difference. Now, what have I got right here? I got a nice little system of equations. So we can solve this. Okay. So now, but we're not going to go all matrix on you. Okay. Yes, you do. All right, so, but what can I do? So I need to eliminate either A1 or D. Which one's gonna be easier? A1, absolutely, right? So I'm gonna take the top equation and do what with it? Run a negative through it, correct? Or times by -1. Boom, boom, boom. Add them up. -3 and 35 is 32. A's go away. 19D minus 3D is 16D. So what is it now? What is our common difference? 2. How do I find my first term now? Plug D in. So let's go to that top equation. So we get 3 equals A1 plus, plus 6, right? 3 times 2 is 6, and you minus 6, and you get A1 is -3. Now we can write our equation. So we get A sub n equals A sub 1, which is -3, plus n minus 1 times our common difference, which is 2. And there we go.
So we're gonna have that formula, like these two formulas on the.
You will have the sum formula, the S formula, not the general one. So that one you got to have down. The one on the left, you got to memorize that one.
And what is that one?
Look at flip it over. It's on your notes. It's always on your notes, Larissa. Okay, so let's look at part B now. So our 9th term is 11 and the 30th term is 74. Okay, so we've got A sub 9. I made that A look like a 9. Equals 11, and so that is A sub 1, which I don't know, plus 9 minus 1, which is 8 times D, and then A sub 30 is 74, and again that's A sub 1, which I don't know, plus 73D. No, 29D, gosh, hello. 29D. All right, and again, we have our system. So we're going to eliminate A, run a negative through the top. 74 minus 11 is 63. A's go away. 29 minus 8 is 21. So D is 3. Correct. Plug it in. Let's plug it in the top one here. So 11 equals A sub 1 plus 8 times 3 is 24. Subtract 24, and A sub 1 is -13. Okay, write your formula. A sub n equals what? -13 plus n minus 1 times 3. Good. Now, oftentimes on your test, it'll want you to distribute that 3 and combine your like terms there. Okay. So with this one, we'd have 3n minus -13 plus 3n minus 3, so we have 3n minus 16. Okay, so now it says find the following sums. So let's pull out our sum formula here. Okay, so our sum formula, which is S sub n, is n over 2 times the first term plus the nth term. Okay, so look at this first one. Now, how many terms are there? This is what we got to figure out here. Okay, so what's my common difference? 2, and I'm going on, and I start at 1 and I go up to 59. So how many terms have I got? You think?
29.
Okay, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. So 19 would be 10, which means 39 would be 20, which means 59 would be 30. So we got 30 terms. You got to include that first one, right? So we want the sum of the first 30 terms. Well, now it's easy, right? That gives us 30 over 2 times the first term plus the last term. So that gives us 30 over 2 times 60. Well, half of 60 is 30, and 30 squared is 900. Now, what if we couldn't figure out, or it was a little more complicated than this, and we couldn't figure out that 59 was the 30th term. So I couldn't figure out what n was. What could we do to find that?
You could do something.
You're right, I could do something.
Plug in some for a different n.
What we could do is we could figure out
The nth.
the nth term, exactly. So we could say, okay, the first term is 1, the second term is 3. Okay, actually we can just derive a formula here. So we've got a sub 1, or a sub n is equal to a sub 1 plus n minus 1 times 2. Correct? Does that make sense? So I've got my first term and my common difference. So now I get, distribute my 2, so I get a sub n is equal to 2n minus 1. Now, I know the nth term is 59, right? So I'm going to set 2n minus 1 equal to 59, and I'm going to solve for n. So I add 1, divide by 2, and I get n is 30. So I know 59 is my 30th term. So that's how you can find, if you can't figure out what term that is, that last one is, plug it into the nth term formula. Plug that value in and solve for n. Okay? Does that make sense to everybody? Are we sure? Sure. Sure. Okay. All right, part B. So now, okay, so again, so our sum, now this is going up to the nth term. So we have S sub n is equal to n over 2 times, what's my first term? 2. What's my last term? 2n. Okay, so what do I get here? So what happens to my 2's? As I distribute this n over 2, what happens to all the 2's? They're all going to go away, right? So what's going to be left? N plus n squared. And again, if you don't see that, I got 2n over 2 plus 2n squared over 2. And then all the n's go away, so you're going to wind up with n plus n squared. And there's your final answer.
Because you're distributing that
N over 2, correct. Okay. And then so whatever n is, if I decided that, you know, I wanted the sum of the first 20 terms, I plug 20 in for n and go. If I wanted the first 5 terms, I plug 5 in for n and go. Pretty easy stuff. All right, part C, we'll go back to a little summation notation. By the way, Mr. Ash was so happy that we're introducing summations to you guys, so. Because you see that in calculus a lot. All right, so we've got now from n is 1 to 100 of n here. Okay. So we want the sum. So the sum, so how many terms have I got when we do summations? Okay, let me ask you this. Let me ask a better question. What's my common difference here? If it's just n. Yeah, common difference is going to be 1, right? So what's my first term? Okay, good. So a sub 1 is 1. What's my 100th term? Okay, right. And if it's a sub 100, then it's 100. Good. There's our first term, our second term, or our last term. We're ready to roll. So S sub 100 equals 100 over 2 times 1 plus 100. Or I get 50 times 101. Now remember last section when we did those summations? Okay, we used a little different formula for that, but you can also see that these work for sequences. Remember that list of formulas that I gave you, told you to write down on your lecture notes? Where we did, okay, yeah, the summation from k equals 1 to n of k. Right, and then we did that whole thing. Well, that's another way to write the formula right there. Okay. All right, let's look at number 35. Okay, so number 35 here again. This is an nth term. So our sum then is n over 2 times first term, 1 last term, 2n minus 1, which gives us n over 2 times 2n, which is, as the 2's cancel, which is n squared. Okay, so the corner section of a football stadium has 15 seats in the first row and 40 rows in all. Each successive row contains 2 additional seats. So how many seats are in this section? How many total seats are in this section? Okay, so now we got to write down what we know. So we know that D equals 2. Excellent. What else do we know? A sub 1 is 15. Good. And what is N? N is 40. Right? D is 2. N is 40. There's 40 rows. Okay? So now if we want the total number of rows, we want the sum. Correct? We don't want... Now if it asks for how many seats are in the 15th row, then we'd want the nth formula, or the nth term formula. But since we want just the total number of seats in the section, now we do the sum. So we get the sum of the first 40 terms, the first 40 rows is 40 over 2 times the first term, which is 15, plus the last term. Ooh. Okay, we got to figure out how many seats are in that last row, right? So what formula are we going to use for that? The nth term formula, right? So that one is, okay, I'm writing that down here on the bottom because we're not doing the calculator stuff. So that's A sub 40 equals the first term, which is 15, plus n minus 1, which is 39, times our common difference, which is 2. All right, so 39 times 2 is 78 plus 15.
How do you know it's 2?
Because it said each successive row contains 2 additional seats, right? We understand that?
Yes.
Okay. So, okay, Jake, so what'd you get on all that mess? 93? So there's 93 seats in the 40th row. So now we just plug in 93 right there. And now we plug in chug. So half of 40 is 20. 15 and 93 is 108. 20 times 108 is 2160. So there are 2,160 seats in that section.